João. Thank you, Sylvia. If I speak like this, you cannot hear. Yes, back there. Yeah, okay. Thank you for the invitation, João, Sylvia. Thank you for setting up everything. Thanks everybody for coming. I know this is probably quite far your respective research areas, but well, I hope there's still going to be some potential lines of intersection or like some examples or some things that could be interesting or relevant to your respective fields. Also, I'd like to hear feedback, of course, since you're working in quite different areas than mine. Yeah, so hope it's going to be interesting for you as well, and also for people on Zoom that I don't know, but yeah, thank you for coming. I think this is going to be shorter than the 45 minutes for sure. This is basically an attempt to summarize some ideas that I'm developing in different papers in the context of my postdoc project here at the center. It's still, I would say it's still like a mess, but there's still quite a lot of things together that I'm trying to distinguish a little bit. So bear with me on that. For sure, there are going to be some things that maybe there's some jump from here and there, but the idea is that I'm trying to identify here some specific clusters of questions and hypotheses and issues, and also some specific objects and cases that I'm studying in more detail in the papers. And I'm going to be a bit reading and a bit commenting and a bit, because that's how I usually do, so I don't get too lost in with commentaries. So it's, yeah, okay. So yeah, I put the title with this question mark, of course, music recommender systems and data sets of music aesthetics, precisely because what I'm doing is trying in a way to question these mutual influences that it seems to me are happening nowadays between data sciences, artificial intelligence more generally, and issues of music aesthetics. But we don't know exactly what is the scope of this influence, how it is happening, to which extent, and in which case. So that's one of the things that I'm trying to distinguish, sort of look at the epistemological basis of these kinds of technologies, and also focusing a little bit on how certain type of epistemology, a certain type of technical and scientific way of approaching music and issues in music, like music aesthetic experience, consumption behavior, and so on and so on, how these influence both issues more strictly about aesthetics of music, but also more generally like social and even political issues. So the case of recommender systems so far has not been much studied within philosophy of technology and or philosophy of science or philosophy of cognitive sciences. There is some work on the ethics of recommender systems in general, like people like Floridi or like these well-known people working in philosophy of technology have written about that, but so far it's mostly an area that is highly studied by data scientists. So they keep proposing different techniques, different algorithms, and so on and so on, and by sociologists working in sociology of music. So here what I'm trying to do is sort of bring, and I'm going to try to argue why I think that's relevant, to bring this to the debate on epistemology and philosophy of technology and philosophy of science, because I think that bears very central implications for some questions that are quite, at the end of the day, quite classical in philosophy of science. So basically a guiding general hypothesis that I'm developing is that music recommender systems are characterized by complex interplays between sciences, technologies, and aesthetics that do demand further clarification. So like all of that's kind of happening together in the practice, in the very exercise or in the functioning of these technologies. And we need, or I'm trying at least to identify what we have there of scientific, what we have of technological, and how the science sort of helps to reshape musical cultures or music cognition and so on. And yeah, and of course I do that. I'm not going to go into details, but I do that using a bunch of authors, like there are some more to philosophy of technology, others more philosophy of cognitive sciences, phenomenology, and so on. But about that, I'm not going to go so much into detail today. Some sort of introductory remark. These sort of almost, how do you say, not parallel, but like using here synonym artificial intelligence in data science. I know that that's not very precise. This is a diagram that sort of helps you understand, because my only point is that they do overlap in certain aspects. And the main point why I'm using sometimes even more data sciences or focusing more on data science than on AI is because, and we have talked about this with João some other day, that was commented, sometimes when we started talking about these things aiming at AI, we almost immediately transform AI into this entity and then start asking if this entity can know music or can understand music or can do something else, music or about any other topic. And what interests me here is to sort of bring this field to more concrete things that they use, more concrete techniques that they use. They have a lot to do with the statistics, and at the end of the day, it has a lot to do with mathematization. So what I'm interested in asking here is, for example, like to which extent statistics help us to analyze music or music aesthetic experience or certain specific algorithms. Some are here, others is in the specialized literature. But when I'm talking about AI here, what I wanted to sort of bring the attention to is that we're talking about these sort of very concrete mathematical methods, and they are the ones being used in the system. So, and basically, yeah, as I was saying, they do overlap a lot, data sciences and AI, in the type of research, development, and applications they make. Yeah, this is, I'm not going to comment, but just I think it's a very good reference. This is a paper from last year called the Epistemological Foundations of Data Science, a Critical Review, that I think clarifies this very well. And we almost can look at this as an epistemological foundation of AI, a critical review, because they deal with a lot of methods that are also part of the typical AI research. And it's also one of the papers that I use sort of as inspiration for my work. Just before I move on, and also so we are on the same page, by recommender systems, I don't know if you all have an idea of what this is, but I'm talking about this, what is sort of popularly known as these personalization algorithms, or algorithms that, when you enter whatever platform, sort of filters the kind of contents that are going to be suggested to you or that are going to be presented to you. So there's a whole field in designing algorithms to do that, optimized by different types of criteria and with different goals. But yeah, that's what I'm going to be talking about more concretely. So just a bit of a historical overview, like between the interplays between music and AI, very broadly, the principles of AI, as I call sometimes, quite very old. Like probably a lot of you have already heard this quote from Ada Lovelace talking about the analytical engine. This Athanasius Kircher, there was this kind of inventor, ingenious polymath, developed this actually empirical device called the arca musica rhythmica that could also compose melodies just purely using algorithmic procedures in the 17th century. Since the 50s already, with the use of computational algorithms like Markov chains and so on, there has been a lot of research and attempts to implement this automatization of musical composition, and all of this, which is very studied, is still studied. It kind of enters in this domain of trying to automatize human creativity. Like that's basically where this thing is mostly studied. But in my case, in my research, what I'm inspired by certain authors, for example, Lev Manovich, that is a big reference here, who is a computer scientist and art historian. What I'm trying to analyze more is how the use of artificial intelligence and data science techniques in the field of recommendation, it entails other kinds of problematics that do not have to do with automatizing creativity, but that influences other aspects of, for instance, social aspects of musical cultures. And in some extent, it also influences creativity and creative processes, although it's not meant to do that. But as I will discuss soon, it has an impact on that. And it sort of brings back a series of quite classical problems on the philosophy of science that, that in the automatization of creativity are not that clear. But in this kind of very popular, quite massively used technology nowadays, I think they entail certain kinds of philosophical problems. Just also some notes about the idea of music aesthetics that I'm putting here. These I put because I think it's important. Usually when we're talking about AI and culture or AI and aesthetics, people jump to this quite oversimplified conclusion that we're talking about beauty, or they necessarily are talking about fine arts, but the domain of aesthetics philosophically and in music, but in different domains, entail actually several other aspects and several other concepts that do not have anything to do with beauty or the fine arts. for instance, concepts of style, perception, judgment, criticism. There's a whole bunch of even practices, something's more empirical. So when I talk about music aesthetics and when I try to question the role of artificial intelligence in music aesthetic nowadays, I'm taking this broader view. I'm not really considering just the case of if AI can, you know, sound like a pretty song or something like that, that there is a field of study for that, but it's not what I'm interested in. I mean, I've been working on this diagram. It's not actually complete yet, but just to have an idea, like to have this aspect more of aesthetics as an attempt to make a theory or models or create a certain understanding about certain objects, for instance, works of art, music, and so on. But then you also have a more empirical dimension that the first is Dieter Mersch called the epistemologies of aesthetics that are more to do with the practices, for example, creativity, taste, perception, and so on. And of course, you have all this in between, because in science you can have models and these models can be used for creativity, but then at the same time, practices in a different context can emerge, like from them a certain common sense or certain practices or patterns and habits that then suggest other models that can be studied and theorized in the theoretical domain. So yeah, I think it involves, this category of the aesthetics involves a lot of key concepts that are not just the beauty, it goes much beyond that. And I'm interested in how AI is transforming a bunch of these things, basically. So about recommender systems, this is a very interesting quote before I present the core part, which is how these two things are connected. I put this quote here because Brian Whitman, this is from the PhD thesis of this guy called Brian Whitman, which is he's a computer scientist. And in this thesis from 2005, he presents a machine learning model for doing music recommendation. And he transformed this into a startup called Econest some years later. And later, this was acquired by Spotify. So this technology that he developed in MIT, you know, like in 6-7 years later, became the main technology powering one of the most important companies nowadays. So, and he says this is from the introduction, which I think it gives this kind of more intuitive overview on what's the agenda behind it. It says, so we want to find music that we like. We want to have our portable device to know which songs to play. For example, only play jazz at night or never play anything sad when it's raining. But we are faced with a glut of data that gets worse every day. And yet we still search for a music by file name, simple metadata such as artist or album title, through sales-based recommendation systems. Computers are better at making sense of large amounts of data. They have more patience and don't give up that easily. The goal of our work, in this case, his PhD thesis, is to make machines link music to semantic features or the outside world. And here's also a very interesting part. If we do it right, they would have the same knowledge about the music as the aggregate of their entire community. They can tell you about similar sounding music or recommend new artists no one has heard yet, or make playlists for you. So like this is a kind of a general motto of this research field. And there's quite a lot of research in data sciences about this nowadays. Like they have this big conference, so they publish a lot of algorithms and optimization versions of existing algorithms to, let's say, try to perform this kind of task. And now also already going beyond. So like they discuss things, for instance, to make specific algorithms for people that are interested in exploring more a certain musical data set, or for people that really don't want to have any kind of work, that you just want to have some semantic entry. I want music for this or that, and then it can compose some playlists for you for that. So they develop this kind of thing. And to give, here's a bit of a more technical thing. The first quote is from the main book on recommender systems that in a way says the same thing of the other quote, but in more general terms. But just to give you like a more or less concrete and intuitive example, like basically you can have, if you have digitalized music, you could have, for example, a table with millions of rows showing specific features, for example, songs that have lyrics, or songs that have a lot of instruments, or songs that are very loud, or songs that are very quiet, and so on. And you can also have a huge Excel table with the play logs. So for example, with the consumption behavior of people, like music that people have chosen before. And you can basically cross this using algorithms that can then create a model to predict from this data set, which other songs this person or this user is likely to consume or not. So this is the kind of task, but it gets enormously more complicated because you can have a lot of data there, not just the audio file. And from an audio file, you can have a lot of features that you can extract, and ones that we cannot yet extract because we don't have the technology for that. But you can imagine how crossing these things in an Excel table with billions of rows, and then you need also write algorithms to actually cross that information correctly and create the accurate models for you. This, I'm not going to go into detail, but this is from Spotify. It is from a presentation of one of their engineers. It's from 2016, so for sure it's not updated. But this part here that are marked in blue is just to give you an idea, because in the case of Spotify, and in the case of this service only, that is Discover Weekly playlist, you have there, for example, the play logs, that is basically the consumption behavior of each user. You have track metadata, like the album title, when it was released, whatever. And then you also have this thing of web crawling, because then they can also take into account data from news, blogs, comments, and so on. You need different types of algorithms to process that. So for example, for processing the text, you need these language processors. For tracking, for processing the play logs, they use another thing, that is that collaborative filtering model there. There is a specific algorithm to process like this consumption behavior. And then you have also their raw audio there in the corner, which you need a different kind of algorithm to process audio information and identify relevant information there. And then imagine that you're going to cross all of that in this model here. And then you can generate this kind of playlist that, for example, in Spotify is known as Discover Weekly. Yeah? But then they have also other sorts of personalization, personalized playlists, just to give an idea of how this thing can get more complicated on a technical level. And but my point that I'm trying to develop here is that doing that kind of practice and the circulation, let's say the exercise of that kind of technology that we can see, for example, here in that blue part, it impacts directly music aesthetics on at least 3 fronts that I try to divide now as like a more epistemological area, a more normative impact, and a more phenomenological impact, which is what I'm trying to distinguish in at least 2 papers that I'm working right now. So basically, this kind of technology, it has this epistemological part in the sense that it functions as a sort of science or method of music. So to the extent that it is capable of analyzing several audio data in order to identify patterns of that. So for example, automatically evaluate if the song belongs to a certain style or not, if it has certain features or not, if it matches features that a certain bunch of songs have or not. So to the extent that they try to do that automatically, it has this kind of attempt of creating a model, yeah, like that is not very different from a music analysis that a musicology could make in a way, but they do this for billions of songs and automatically, because you cannot do that by hand, of course. And it also has an even more interesting epistemological function due to the extent that they try to map not only consumption behavior, but aesthetic experiences or the psychological effects of music. So they try to use this kind of information that we have here, for example, comments and so on, and the play logs, and when you listen to the song, etc., to try to create models that would explain that, you know, like, okay, perhaps this kind of song elicited this kind of effect in this kind of person, in this kind of context, and so on. So it has this kind of, even if it's not the main intention, because these are commercial tools, it entails a certain kind of, or it implies a certain kind of knowledge that they want to use in order to generate more recommendations. And you have here even something that is quite funny, that is a subfield in data science that they call, or like a research problem that they call hit song science, that they try to analyze like zillions of songs that were like hits on certain periods to identify what would be the patterns that make a hit song. For example, like they have this kind of trying to identify what would be the fundamentals of certain aesthetic topics in music. And then you have other epistemological, how to say, well, basically opportunities or research paths that it opens. So I found, for example, there's this paper from some psychologists, David Greenberg and Peter Renfro that is called the Music and Big Data New Frontier, that they propose precisely that same kind of technology, at the end of the day, although there it is using and being, let's say, optimized for certain commercial purposes, it suggests also other kind of uses. And then they say, and I quote, they say, these two psychologists, we propose that the merging of these technologies can create a new age in music psychology and exponentially expand the present knowledge and scope of the field by scientifically mapping how music changes behavior and health in the short and long term. Music big data can lead to future health initiatives, including the development of new evidence-based treatment modalities to be utilized by medical physicians and mental health practitioners. And here's something important, because they say industry and streaming services can use these insights to optimize their technologies and develop music-based health and wellness platforms aimed at improving well-being of its users, ultimately impacting the way music is used by millions of people globally. So like you have this kind of more scientific intention behind this kind of project that is very mixed with the commercial one, that sometimes it's difficult to know if the point is like more practical services or the point is, for example, even health initiatives. And of course, an important question here is that to which extent this kind of mathematical-based epistemology of music, based on these kinds of systems and algorithms, can actually provide the kind of information, to what extent you can conceive this kind of uses, for example, health-based, based on that, which is something that is not really discussed, like it's something that's kind of there only. Still about this epistemology part, that is the one that I'm working the most now. One more thing that I wanted to comment, there was, yeah, of course, yeah, that basically in the literature that is being developed around this kind of technologies, as I was saying, like you have a lot of this commercial vein that is quite explicit, of course. The industry develops these much more than academia nowadays. But my point here is that whether it is intentionally or not, they inherited this kind of mathematical-based epistemology of music in the way that they are trying to, or this mathematical-based aesthetics of music in the way they're trying to develop these technologies. And of course, this mathematization of music is something that has been widely discussed, like in history. And the tensions between this and the phenomenological part, for example, or to which extent that this can cover all aspects of the aesthetic experience and so on, is not so well discussed. But this is something that I'm trying to bring, that I think we still need to develop more, this, to which extent the knowledge generated by these kinds of technologies are, let's say, accurate or relevant, or to which extent they actually introduce new knowledge that previous methods could not develop, or that is something that is still not clear in how that is being developed. So like on the one hand, understanding that they have this epistemological role, what I'm trying to do is to analyze the limits and the advances in that field. But also on the other hand, and I'll speak a bit more about this in the end, we can discuss a little bit the social and cultural implications of this kind of epistemology to sort of control the musical culture, like by promoting certain musical cultures or by promoting certain listening practice and so on. So another part is this normativity. I won't go into much detail, but this is very interesting because the idea of using scientific models in music composition is not new in history. There's quite a long record of that. There is a case, for example, in the 18th century, like when they studied the physics of the overtones and the natural harmonics and so on, like there was this important composer called Jean-Philippe Rameau that developed both a theoretical model and tried to apply that as a compositional background or as a compositional method. In a way, using that kind of the physics of overtones as a sort of naturalization of a certain musical language, which was his. Later, it also happened in the 19th century with Helmholtz. That is this physician, you probably all know about him, that also tried to sort of naturalize the tonal music, European tonal music, with the science of acoustics and the physiology that he was, psychophysiology that he was developing. And in a way, also, again, it's trying to make this transform into a standard or do this sort of naturalization of certain aesthetic principles. And in a way, it seems to me that this kind of technology nowadays also do the same, to the extent that they start promoting, or they are the tools to analyze how certain music, how certain songs impact people. In a way, they start giving these frameworks of how a song has to be in order to achieve certain goals. So they make a sort of naturalization of certain aesthetic principles. And most importantly, what I'm discussing in this normativity part is that there is always this tension, as there was in the case of the past of Rameau and Helmholtz and so on. And nowadays there's this tension between, with the scientific method, to which extent you are identifying a fundamental pattern and to which extent you are just reinforcing certain or naturalizing certain patterns that you could find because those are the ones that your method allowed you to reach, or because it interests you commercially, ideologically, whatever it could be. You know? And this last part that I'm trying to develop in a separate paper is that this kind of method used to understand the user's behavior and the music data sets, it's interesting to notice that they are experienced by the user as a certain type of aesthetic experience, in which certain things come to your field of attention, so to speak, or other things don't appear there. So when you interact with this kind of platform, of course, these kinds of underlying knowledge that pre-organizes everything for you there, it ends up having an impact on also how you reorganize your habits, the beliefs, and so on. So this is something that I'm also trying to study. As you can see, they are like somehow all integrated, because we're talking here about the technology that tries to gain certain knowledge about users and about a certain object, that is music in this case. They do so by selecting certain sources of information that they think should be relevant to acquire that knowledge, and by using certain algorithms that should be able to process that and actually give you what is relevant of that. But then it immediately, of course, and inevitably, that starts sort of feedbacking in how that field is organized, like both in the level of, let's say, composition, and also in the level of the experiences, the beliefs, the expectations, and so on. Going already towards the final part, this I'm also not going into detail because it's something a bit more specific, but of course there's this problem in the literature, especially in AI, about the abductive reasoning. And of course, this is one of the things that I try to discuss, like to which extent this limitation can influence this kind of epistemology, for example, and therefore the kind of principles that it promotes in the musical cultures around. So the idea that by looking at the right kind of data and identifying the right kind of underlying pattern, you can provide the fundamentals that can be used, be it for composition or for, you know, designing musical products and so on. Like this, in a way, falls again, like, or, you know, like it has this challenge that at the end of the day, it's an inductive-deductive method. But and then, of course, there's this question: to which extent the aesthetic habits, beliefs, experiences, creativity, and so on can survive on the base of that. An analogy that I was thinking here is, for example, like if you take Jean-Philippe Rameau that tried to give the fundamentals of music in the physics of overtones of the 18th century, like that cannot explain the music of Beethoven, for instance. So like there's always this tension that, you know, if Beethoven were to go to the principles, the scientific principles of the physics of Jean-Philippe Rameau, he couldn't do the modulations that he was doing. So like there's always this problem that when you're working with certain fixed stacks of patterns, to which extent that is like a fundamental natural, and to which extent that is just one aspect, but then that can be reconsidered and expanded, you know. And this is something that I'm also discussing, but I'm not going to go into details here. And I would have only now some final remarks. I think I still have time, right? Yeah, like it's 5 minutes really. There's just kind of a summary of, I don't know yet if this is going to enter the papers, but I was just trying to organize a little bit because for me, this whole problem, like the idea of using data sciences to develop a kind of a new popular and global epistemology of music, that is in a way what it does in practice, even if it does not have scientific, but only commercial interest there. It kind of, and that I try to present here as an overview. And my point here is that what it seems to me is that this kind of data science-driven and AI-driven music aesthetics is an expression of this kind of scientificization, so to speak, of all domains of human experience, and a certain type of scientificization, of course. And this attitude towards science, or the scientific naturalization, or attempted to make a scientific naturalization of a certain phenomenon, in this case, the music aesthetics, was strongly criticized, for example, by Husserl in the early 20th century, and even more interesting by Karl Stumpf, which was Husserl's professor, and made this criticism in the domain of music psychology in the 19th century in his debate with Helmholtz. So Helmholtz trying to make this kind of naturalistic and mathematics-based fundamentals from music aesthetics. And Husserl's criticizing the limits of this kind of approach, like that, okay, with that you can get a certain type of knowledge, but that does not give you all the knowledge of what there is in that kind of phenomenon. And of course, the scientific and commercial success of recommender systems, and more generally, the scientific and commercial success of AI in general, I think it makes it clear which side of the debate predominates in contemporary culture. And my point in the kind of argumentation that I'm trying to develop in those lines, while acknowledging the relevance of that kind of tool and the lines of research that it opens for study of certain parts of music aesthetics and certain aspects of musical phenomena, while acknowledging that the criticism that I'm trying to develop, following Stumpf, Husserl, and Alfred Schutz, and many others in this lineage, more phenomenological lineage, you can put like that, is that we have to remember that without integrating this highly abstract and mathematized knowledge with our so-called natural attitude, so to speak, we risk departing from a human level experiences and enter this quite different domain of data and algorithms. And what seems more problematic, we risk entering this new domain, this post-human domain we could call, and then use it to remodel the human experience or the human intersubjective experience in a way, like in the sense that that starts mediating again our interaction with this kind of phenomenon. So for example, instead of using data sciences or these kinds of technologies in general to uplift individual and social experiences of music, we start generating knowledge about it based on data that only computers can make sense of, ultimately, and data that do not really indicate anything music to humans in a natural attitude, so to speak. And this is all just to say and to remind, that's the final point, that this kind of technology revive and put forward once again central philosophical problems that were left unresolved, and even most important, that were not really debated enough, it seems to me. So for example, this debate between Stumpf and Husserl, between the mathematization, naturalization on the one hand, and the phenomenological and the more psychological one on the other hand, it seems that one just went over the other, like that you went much faster. And we don't know yet how to integrate that. And it seems to me that it's a central point to try to integrate that eventually, at least. So, and this is the final point, the attempt to make a sort of theory-free or psychology-free or phenomenology-free music aesthetics based on data analysis only, and the decision to use this kind of methodological procedures and them only to approach certain domains of human experience, like music aesthetics. This all entails, and that's what I try to suggest, at least with those examples, it entails not only aesthetic, but also philosophical and social implications from certain views on what science is and on what science should be used for in this case. And that's all that I had to say. Thank you very much.